Hello and welcome all on Unacademy JEE English, guys. This is a channel, guys, launched by Unacademy where each and every topic for IT JEE will be taught in pure English. And I'm Rahul Kaushik, guys. Today I'm going to take a very important topic, solid state, and within this topic there is a subtopic named as defects in the crystal. So guys, today I'm going to take defects in the crystal, and that's important from JEE Mains point of view, JEE Advanced point of view. So guys, let's start it. But before we start this topic, guys, first let me tell you something about myself. Yes, guys, I'm Rahul Kaushik, guys. I worked in Bansa Classes Kota since 2010 to 2020. So continuous 10 years, guys, I worked there. And during my tenure there, I was head of department since 2015 to 20. And guys, after that, I co-founded my own organization, Zigyan Education Private Limited, and now, along with Zigyan, I am here on Unacademy, India's largest and fastest growing online platform, to share all my experience and knowledge with you guys. Okay, and I mentored 2000 plus successful IITians in last 10 years in Bansa classes, and now, guys, I'm mentoring you guys. And first, let me tell you about this channel. JEE English. Guys, this channel is launched by an academy especially for those students who were facing issues with the Hindi. And now you guys can learn each and every concept of JEE in pure English. Okay, guys. And the purpose of this channel is just for those students, to help those students who are facing issues of related to language. Because in India, most of the student can easily understand English, and guys, we are there on the Telegram as well. So on Telegram, guys, this is our channel name, JEE underscore English, and you can join this channel. You can join this channel, and link for this channel is given in the description part of this video. Okay, guys. Hi Tech Cricket. Good evening. Hi Triveni. Yes, Triveni, but Bragg's equation is not part of syllabus. Neither it is part of IT JEE nor it is part of JEE Advanced. So, what would you do with the Bragg's equation? This is not part of syllabus. Okay. So, guys, now I will tell you some simple steps how you can subscribe to Unacademy. There are simple steps, guys. Just go to Play Store or App Store, download Unacademy's learning app. Once you have downloaded it, guys, install it. And after installation, guys, just click on the plus. So once you are clicking on the plus, guys, you will be getting IIT JEE and NEET UG. So select the IIT JEE box, and once, guys, you have selected the IIT JEE box, guys, then hit the subscription button. Okay, and guys, once you have hit the subscription button, once you have hit it, you will be getting these options. So here I'm telling you, guys, hi Menak, hi Vidya, I will take your questions as well. Don't worry, I will take your questions. So this is my code, guys, Rahul Kim. If you are applying this code, then you have to pay 50,000 rupees for 2 years. So guys, remember this code. It is very important. Rahul Kim. Rahul, my name, and Chem for chemistry, guys, and apply it. Otherwise, guys, let me tell you about the fees. For 1 year, you have to pay 38,000 if you are not applying my code. But if you are applying it, guys, you have to pay 34,000. And for 2 year, guys, for 2 year, you have to pay 56,000 if you are not applying my code. And guys, if you are applying it, yes, you have to pay 50,400 rupees. So guys, remember this code. This code will get you a huge discount. Okay, guys. So guys, this is my code Rahul Game, and this is the fees for 12 months. This is the fees for 24 months. Okay, guys. Yes. Any doubt, guys, please ask. So now there are some questions. First, I will take those questions, and then I will start defects in the crystal. So Vidya Valasri, hi Vidya, where are you from? When will you start ionic equilibrium? Yes, Vidya, tomorrow onward I am starting chemical equilibrium in 11th class. So tomorrow is Tuesday. So TTS, Tuesday, Thursday, Saturday. ETS. class is for 12th, and then we have MWF, and this class is for 11th. So tomorrow is Wednesday, so I'm starting chemical equilibrium, and after chemical equilibrium we can take ionic equilibrium, right? And Menak Chanda is asking, sir, please recommend a problem solving book. So Menak, I will say that instead of going for a book, you should follow material of some institute, material of any reputed institute. Preferably, if you can solve the quota material, any institute, Bansal classes material is best if you can get it. Bansal classes or any other institute. Yes, that would be best. Ayush Pandey, sir, can Unacademy also start computer science for class 12? I cannot comment on this. Ayush, for this, I'm not the right person. So, guys, I hope now you got your answers, guys. Yes, tell me, guys. So, are you ready for today's class? Are you ready for it? But I can't see your thumbs up or anything. Yes, guys, are you ready for today's class? Tell me, guys. Hello, Ravish. Hi, Amy. So, today we are here with the defects. Yes, guys, please tell me. Are you ready for today's class? Tell me, guys. That's great. That's great. Not an issue. Just solve this. So let's start. Defects in the crystals. Let's start it, guys. Defects in the crystals. Okay. So ready, Manak? Only Manak is ready. There are 15 students. I can't see your likes as well. First of all, don't forget to like this lecture, guys, because today I'm going to take so many things. And JEE Main, almost every year now they have to make at least 15-16 problems in a year. So every time they are asking it, guys. So please like it and share this lecture as much as you can, so that your friends can also enjoy it and watch it. Ready, guys? So let's start, guys. This is what I call, these are examples of solid, and what we have done till today. So we have done unit cell. What types of unit cell are there? We have done crystal systems, right? Good afternoon, Sankaran. And after this, guys, we have done voids. After this, guys, we have done ionic solids. And in ionic solids, which are the solids which we have already covered, guys? NaCl and cesium chloride, ZnS, CaF2, Na2O, and diamond. Yes, guys. I've told you each and everything about these ionic solids. What will be the coordination number of cation? What will be the coordination number of anion? Everything I have told you, guys. Okay. So these are all the solids. Now, guys, what do you mean by defects? So let's start defects, guys. So what are defects, guys? So, guys, defect are basically, what I can say. If I see, suppose this is pen. So this pen is consist of constituent particles, and I told you that in solid state I will consider all the constituent particles as the solid spheres. So all the constituent particle in this pen are arranged, right? Yes, Manak, I have covered the real gas in state of matter. I've taken two lectures, one for van der Waals gas, and then there was second lecture that was based on liquefaction, critical parameters. So everything is covered in the gaseous state lecture. Yes, you can watch that. So, guys, here if I talk about it, suppose these particles are arranged in a crystal. Okay, Yes, this is a crystal, guys. Here you can see everything is perfectly arranged. Everything, right? These can be cation, these can be anion, or these this can be a covalent solid where these can be atoms. So if atoms or constituent particles are properly arranged, then this crystal is called ideal or perfect. But guys, in this world, nothing is perfect. Neither I am nor you. Nothing. Nothing you can say in perfect. Yes, except God, nothing is perfect, guys. So what do you mean by irregularities? What happens, guys, now? Suppose there are some irregularities, like you can observe here. Except this point, everywhere it is uniform, but along this point, some extra atoms are there or some extra ions are there. Then I will call it defect. So, guys, this is irregularity. So, these are basically irregularities in arrangement of constituent particles, right? So, note it down, guys. If you don't have copy and pen, you are wasting your time. You should have a copy and pen with you. So, guys, if this defect is there, means except this point, guys, except this point, everywhere structure is same. I will call it this is not perfect. I will call it this is not perfect, and this crystal is having defect. So defect are of how many types? So guys, we have two types of defect. One is called point defect, another is called line defect. So what is point defect, guys? So if defect is around a point, then it is called point defect, because here in this crystal you can see defects are only around this point. So what is line defect, guys? So now I will explain you the line defect. Yes, suppose I'm making the perfect crystal. Suppose I'm making it perfect crystal, guys. Got it? Yes, guys, this is perfect crystal. Now there are some irregularities or deviations. What kind of deviations? Suppose here I'm getting these deviations, right? So guys, as you can observe here, yes, as you can observe here, there are deviations along this line. So this defect I will call point defect if deviations are around a point, and if deviations are around a line or along a line, around will be a wrong term for line. If deviations are along a line, then it will be line deviation. So guys, there are two defects. One is point defect, another is line defect. So what are point defect? If irregularities or deviations from ideal arrangement are around a point or atom, then such defect is called point defect. Just make this diagram for it. Okay. And if deviations are along a line, if irregularity or deviation from ideal arrangement in entire rovelet is point, then this defect will be called line defect. And guys, combinedly, line and point defect are called crystal defect. So combinedly these two defects, I call them crystal defects. Note it down, guys. Combinedly these two defects are called crystal defects. Yes, guys, tell me, are you facing any issues? Yes, Triveni, Sankaran, Menak, anyone? Are you facing any issues? Done. So, have you noted down these diagrams, guys? Have you noted down? Just note down example of point defect, example of line defect. And combinedly, these defects are called crystalline defects. No doubt. So, guys, now let's move to the next point. Yes. What is thermodynamics of these defects? What is thermodynamics of these defects? So guys, how you can create defect? Can any of you tell me? Yes, you can write in the chat box. How can you create the defects? Tell me guys, is there a way? Is there a way to create the defect? Tell me guys. Heat. Yes, very good. Actually, if I'm taking a crystal, suppose this is the crystal and I start heating it. So in crystal, suppose all particles are arranged perfectly. So what will happen when I will start heating? So once I start heating guys, what will happen? So these particles will start moving. And if these particles will start moving, so perfect arrangement will be broken. And now I can say this arrangement is not perfect. And if arrangement is not perfect guys, then I can say defects are created. So if defects are created guys, in thermodynamic we use this expression delta G is equal to delta H minus T delta S. So when you are heating, defects are creating, so delta G will be negative because process of defect generation is taking place, right? Yes. Yes, fun inside. Definitely, I will take a quiz. I have already taken two quizzes over it. So don't worry, I will take one more. Okay. So now delta G is negative. So when you are providing the heat, so delta H will be positive. So how it can be negative, guys? How it can be negative? This magnitude has to be negative, sorry, positive, and magnitude of T delta S should be greater than magnitude of delta H. Only then this can be negative. Like if it is plus 100, it has to be minus 120 or minus 130. Only then it will be negative. So magnitude of T delta S has to be greater than that, and it should be positive. So entropy delta should be positive. It means entropy should increase. Entropy should increase. So guys, now you know, if entropy is increasing, if entropy is increasing, now you can say, okay, now you can say the thermodynamic of this defect. First of all, energy is required to form a defect. It means defect creation is endothermic process. Note it down. So if delta G is equal to delta H minus T delta S, if this is endothermic guys and you want to create the defect, then there are two factors. One is enthalpy factor, another is entropy factor. Here I can say, because this is positive, I can say enthalpy factor is not favoring, so but still defect are being created. It means entropy factor has to favor it. So I can say creation of defect is entropy driven process. So some thermodynamic is involved. If your thermodynamic is weak, then you will be thinking what sir is saying. And guys, it costs energy to form defect. So when you are providing it guys, so this is not favoring, but it has to favor. So as a result, there should be commensurate or proportional increase. Commensurate means proportional increase in the entropy. And due to this increased entropy, delta S will be positive. And you know guys, when you are heating something, kinetic energy will increase and the molecule will start moving. So once they start moving guys, what will happen? Their entropy will increase. So guys, as you increase the temperature, this magnitude will increase. As you increase the temperature, this magnitude will increase. And once this magnitude is increasing guys, you can say Gibbs free energy or more and more number of defects are being created, right? So guys, now what types of point defect are there? So thermodynamic, I have told you guys, so you can write in a single line. Yes, defect creation is entropy driven process. Defect creation is entropy driven process. Why? Because enthalpy factor does not favor it. Because enthalpy factor does not favor it. Note it down. Done? Yes, guys, please ask me if you have any doubt. Yes, fun inside, Triveni, Emi, Sankaran, anyone. Please ask me, guys. How many of you are making proper notes? Please tell me. How many of you are making proper notes? So note it down. Yes. No one. Yes, I think Triveni is making that. Okay. Emi is also making notes. Amy, I know you are making notes because most of the time your answers are also true. Almost every time. Okay, guys. So now, before this, I told you that if I talk about defects, they are of two types. One is point, another is line. So point defect are further divided into three parts, right? So what are point defect, guys? Point defect, stoichiometric, non-stoichiometric, and impurity. Note it down. So defect can be point defect, defect can be line defect, and if it is point defect, then it can be stoichiometric, non-stoichiometric, stoichiometric, non-stoichiometric, and what? Tell me, guys. Impurity. So there are three types of point defect, right? Line defect we will discuss later on. So now, what do you mean by stoichiometric defect, and what do you mean by non-stoichiometric defect? So stoichiometry, what is stoichiometry? We have already covered in the 11th class. So stoichiometric defect are those defects due to which there is no change in the formula. Suppose I am taking ferrous oxide, and once this is ideal ferrous oxide, and after the defect I am also writing it like this way. So there is no change in the formula of ferrous oxide, so I will call it stoichiometric defect. But guys, what happens if I write it like this? So guys, these are the compounds where you see atoms in fractions, and such compounds are called non-stoichiometric compound. So guys, I will tell you in the later stage how to do this. I will tell you. But if formula of compound get changed, then this defect is called non-stoichiometric. If formula is not changing, then this defect is called stoichiometric. And what is impurity? Impurity you can easily understand. If you are adding some foreign substance, some external substance, so that defect will be called impurity defect. So now I will be taking all the defects in detail. And guys, please ask me if you have any doubt. Please ask, guys. Any doubt? So let's do the stoichiometric defect. Note it down. Note it down. In stoichiometric defects, formula of the compound remains same. Formula of the compound remain same. Right? So formula will not change. So guys, what is vacancy defect here? So stoichiometric defect can be of two types. One is vacancy defect, and there is one more, that is stoichiometric defect. So note it down. Vacancy defect and interstitial defect. Note it down. Yes. So we have vacancy defect, we have interstitial defect. Okay. So what do you mean by vacancy defect? Now I will come to this point. What will happen? What will happen? First I will explain you what is vacancy defect. Suppose I am making it. Yes, I'm making a crystal here. Right guys? So this is the crystal and these dots which you can see, these are the constituent particles. So this defect I'm calling vacancy defect. Why? What will happen now? Now first of all, if I ask you what is the formula, density is equal to mass by volume. So guys, volume of this crystal will be like this. It will be the volume. This is the volume of crystal guys. So now what happens in vacancy defect? Suppose this atom is kept. Now this is no more part of this crystal. Okay guys, the atom which was present here, now suppose it keeps from the crystal. Anyhow, so what will happen? Does the volume of crystal change? Tell me guys. Does the volume of crystal change once one atom or one molecule or one constituent particle escape? Tell me guys. Will the volume of this crystal change or not? Will the volume of this crystal change or not? Volume will not change. But guys, once your molecule is moving out of the crystal, mass will decrease. And if mass decreases, guys, as a result, density will decrease. So, due to vacancy defect, density will decrease. Note it down. So, what is vacancy defect? When some of the lattice sites are vacant, then crystal is said to have vacancy defect. And due to this, density of substance decreases. Note it down guys. Due to this, density of substance decreases. Tell me guys if you have any doubt. Volume will not change. Volume will not change guys. Okay? Yes. Next Triveni and Emi, you are right. So have you noted down? So if someone asks you due to vacancy defect, density will increase, decrease, your answer will be decrease. Now I'm moving to the next point. What is interstitial defect guys? Okay, now I will tell you. Now suppose again I'm taking a crystal. This is the crystal guys. And these points are representing constituent particles, and we can also call these points as crystal sites or lattice sites. So guys, these points are lattice sites. Okay, now what is going on guys? What is going on now? Density will be mass by volume. What happens? This is your crystal. Now suppose there are some extra atoms. They come and occupy these spaces. These spaces guys, yes, I call them vacant sites or interstitial site. Guys, this interstitial is chemical name of vacant. It means empty. So vacant site is there. So if these vacant sites are occupied, so some extra ion is coming, and occupying the vacant sites. As a result, guys, what will happen? Volume will not change, but mass will change. Why? because extra ions or extra atoms are coming. Not ions actually, extra atoms. I will tell you why I'm saying not ions. There can never be ions in this case. So guys, due to this defect, density will increase. Note it down these diagrams. What will happen when after 2 years you will be revising, not 2 year, after 6 months, when you will be revising this topic for your JEE Main and Advanced, these diagrams will make you realize that what you have done today. Yes, this class will become live. That's why I generally ask you guys to make all the diagrams, right? So, interstitial defect. When some constituent occupy an interstitial site, the crystal is said to have interstitial defect. Due to it, density will increase. Due to it, density will increase. Now tell me guys. Now note it down, the most important point. What is that point guys? The above two defect. It means vacancy defect and interstitial defect. These are shown by non-ionic solids. Non-ionic means here these constituent particles can be atoms or molecules. Basically these will be neutral. Why? Because some extra atoms are present or some extra neutral ions are present, that will not cause much problem. But in case of ions guys, what happen if I'm taking NaCl? So guys, if there are 100 Na, then there must be 100 chlorine. So ratio of cation to anion, ratio of cation to anion must be maintained. Okay guys, tell me. Ratio of cation to anion must be maintained. So guys, these vacancy defect and these vacancy defect and interstitial defect I'm talking about, these vacancy defect and interstitial defect I'm talking about, these are shown by only what? Tell me guys. These are shown by only, note it down, non-ionic solids. Because in case of ionic solids, you have to maintain the electrical neutrality. You have to maintain it. Yes, that's important. So, what type of defect ionic compounds will show? Yes, they will show two types of defect: Schottky defect and Frankel defect. What is Schottky defect? I will discuss. Actually, this is the synonym of vacancy defect, and Frankel defect is synonymous to interstitial defect. How? Yes, I will discuss it. So, guys, note it down. Yes, ionic solids must maintain electrical neutrality. So, these shows two types of defect. And what are those defect? One is Schottky defect, another is Frankel defect. Okay. Now, what is Schottky defect, guys? Can you tell me what is Schottky defect? Anyone, guys? Yes, I'm waiting for your answers. Is there anyone who can tell me what is Schottky defect? Be fast. So, guys, now I will tell you. Now I will tell you what is Schottky defect. Suppose I'm taking NaCl. Okay. So this is cation, this is Na. So if there are 100 Na plus, then there must be 100 chloride ion. And Yes. Okay, guys. Now these are cations and anions. These are cations and anions. So if there are 100 cations, there must be 100 anions. I told you that ionic solids must maintain electrical neutrality. Must maintain electrical neutrality. So guys, in this case, what will happen? Like in vacancy defect, what was happening? A constituent particle was missing from its lattice site. Now what will happen? Guys, here if one Na plus is missing, then one chloride has to be missed. Has to be missing. And here guys, if now there are 99 Na plus, there must be 99 chloride. There cannot be 100 chloride ion. So guys, if one cation is missing, then one anion will also be missing. If two cations are missing, then two anion will also be missing. Got it, guys? So because some ions are missing from the lattice site, so again density is equal to mass by volume. So tell me the impact on the density. Yes, Triveni, tell me the impact on the density. Will density increase or decrease? Will density increase or decrease? Yes, density will decrease. Very good. Why? Because two ions are missing. And if two ions are missing, then their mass is also missing, but the volume is same. Yes, Emmy. Very good. So now you know the reason. So guys, in Schottky defect, now just to make these diagrams. These are important. Make these. So if Na plus is missing from here, then chloride will be missing from here. Okay, note it down now. Be fast. Yes, are you done with it? Tell me guys, are you done with it? I will discuss Triveni. No, in Frankel is not like that. First, let me complete it. So, Emmy and Triveni, can you answer? Instead of NaCl, if I take CaCl2, so if one Ca2 plus is missing, how many chloride will be missing? Just tell me. In CaCl2, suppose this Schottky defect is there in CaCl2. So if one cation is missing, so how many anions will be missing? Yes, answer me. Yes, Amy, you are right. So there will be two chloride ions. Why? Because total charge should be maintained. One Ca carries 2 plus, so 2 minus has to be removed. If one 2 plus is missing, then 2 minus has to be removed. And if you are removing 2 minus, now what will happen? Now you can understand. In case of AlCl3, if one Al3 plus is missing, then 3 chloride will be missing. If one Al3 plus is missing, then 3 chloride ions will be missing. Right? I hope now you got it. Because only this way, electrical neutrality can be maintained. Otherwise, guys, you can't maintain. Otherwise, guys, you can't maintain electrical neutrality. Okay, yes, Jindal ji, you are right. Got it? So, have you noted the diagrams? Yes, draw these diagrams, guys, and note down each and every point. Note down each and every point. So, guys, due to Schottky defect, density decreases. So, actual density will be less than theoretical density. So theoretical density will be more and actual will be less. Why? Because some ions are missing. So theoretical minus actual upon theoretical into 100 will give you the percentage of missing units. How many percent of units are missing? The same ratio density will decrease. Right? Note it down. If somebody asks you the missing percentage, guys, then you can find it. Theoretical density minus experimental density upon theoretical density. So guys, now let's move to the next point. In Schottky defect, note it down in your notes. Cations and anions are missing from regular site in such a way so that electrical neutrality is maintained. And these are shown by ionic substances in which cation and anion are of almost similar size. So many a times problem is asked like which of the following solid or ionic crystal shows Schottky defect. So you have to remember these. Actually, these are directly from NCERT. These are directly from NCERT, guys. Okay, now solve these. Remember these all these formulas. So what is the condition for Schottky defect? Ratio of size of cation to anion should be comparable. Should be comparable. Okay, guys, got it now. So now let's move to the Wrinkled Effect. Yes, who will tell me about the Wrinkled Effect? Yes, Amy, Jashan Jindal, Triveni, anyone? Tell me, what is Wrinkled Effect? So guys, today I will be taking quiz. After this class, 6 p.m. and 7 p.m. I will be taking quizzes and you can be part of those quizzes. And quizzes will be taken on the Unacademy app. Yes, questions would be fresh. So be there. Okay, guys. So what is Wrinkled Effect, guys? Now again, Wrinkled Defect and Schottky defect, both type of defect are shown in ionic crystals. So what is Wrinkled Defect? In Wrinkled Defect, guys, we have positive, negative. These are positive, negative, positive, negative. So what will happen now? Cation and anion. So density is equal to mass by volume. So what will happen in this case, guys? Which one is larger, cation or anion? Can anybody tell me which one is larger? Tell me, guys. Cation or anion? No answer. Anion, right. So guys, anion will be like football. So if you are arranging the football in a room, then among these football there will be void, and in those void you cannot place a football because the size of void will be smaller. And in those voids you can place a cricket ball or a golf ball, the small ball. Similarly, guys, if you are saying anion are large, so they will be making the crystal, and normally cation or smaller ion will be occupying the voids, right? And if smaller ion is occupying the void, guys, what will happen in this case? Now I will tell you, this cation is missing, or maybe this cation is missing from its regular site, and it might move here. So what will happen, guys? I will be getting here cation. So one point is this cation is not leaving the crystal. So will there be any impact on the mass? No. Will there be any impact on the volume? No. And if mass and volume are constant, so density will not change. Very important point. Density will not change. Okay, guys. Any doubt, guys? Any doubt? Density will not change. Okay, I'm again telling you. In the previous case, what was happening? This Na plus was leaving the crystal, and this chloride was also leaving the crystal, and the mass the crystal is due to these ions only. So density was mass by volume. So because ions were leaving the crystal, so mass was decreasing, but volume was constant because volume will remain like so, right? So I was saying the density will decrease in Schottky defect. Now what will happen? So when I'm talking about the Frankel defect, this cation was present here. Now it is not leaving the crystal, guys. It is moving from here to here. It is within the crystal. So mass will not change, and density, volume will also not change. This is the volume of this crystal. Mass and volume both are not changing, so density will not change. Right? Density will not change. And if density is not changing, guys, what will happen? Yes, I can call it dislocation defect. Why? Why I'm calling it dislocation defect? Guys, answer is simple. One ion is dislocating. It is not present in its regular location. It is dislocation. Yes, it is not moving from the crystal. So the other name of this defect is dislocation defect. Density will not change, guys. Got it? So note it down. Now here you can see this Ag plus is present here. Instead of this, it is present. So mass will not change, volume will not change, density will not. Right? Note it down. Smaller, smaller ion usually cation is missing from its lattice site and generally present in interstitial site. In this defect, density of crystal remains same. Right? This is also called dislocation defect. Due to it, density will remain unchanged, and this defect is shown by these ions. Why? In this defect, in Schottky defect, I was telling you guys. Okay, Osho. So guys, in Schottky defect, I told you that size of cation and anion should be comparable. But here I am telling you guys that size of cation should be much smaller than the size of anion. Why? So that your cation can easily move, right? And due to Wrinkled effect, dielectric constant increases. Note it down. And it will increase the conductivity. Why? Because your ion is moving. Because your ion is moving, so it will also improve the conductivity of solid. Guys, note down all these points. These are very important points. Yes. Now I'm coming to the next point. If you can find here AGBR in Frankel, and this AGBR was also present in the Schottky defect. Yes, this was the AGBR. So guys, AGBR can exhibit both type of defect, Schottky as well as Frankel. Why? Because the ratio of size of AG plus to BR is almost like this. It is neither very small nor very large. So it can exhibit both types of defect. Guys, note it down. This line is from NCERT. Due to Frankel defect, dielectric constant increases. Very important, and I personally think in JEE Advanced this year or next year or after next year, this problem will be definitely asked. Right? Yes, Arj, it can show. Actually, chemistry, I cannot show exactly why it shows both type of defect. Chemistry is observation based. We have seen that this type of defect, Frankel as well as Schottky, both type of defect are found in it. So we say it, and now I can say its size is like this. It can exhibit both type of defect, right? So how problem will be asked? Let me ask a problem. Do this one. Just solve it. Miss Triveni, be fast, guys. Be fast. Calculate the average total number of ions in this spheroid structure per unit cell if there is shortcut effect of one anion per unit cell. Yes, sirs. Osho, Triveni, ask me. Ask me any doubt if you have. No doubts. So what is ZNS spheroid? Actually, there are four ZNS units which are present in a unit cell. So now let me make that unit cell. Okay, this is the unit cell, guys. Now I'm dividing it into 8 parts. Done, guys. So here, this is sulfide ion at the corner and face centers. Where is Zn2 plus? So one Zn2 plus will be here. One will be diagonally opposite. One will be here and another will be diagonally opposite. So guys, this is Zn2 plus. So overall if you calculate it, there are 4 Zn2 plus ions and there are 4 sulfides, so there are total 8 ions, right? Alternatively, yes. So there are 8 ions. So now what will happen? I am showing you the crystal like this way. Suppose this is the crystal I am showing. So now it says defect of one anion per unit cell. If I remove one anion, one cation has to go. So guys, how many ions will be there now in one unit cell? Count them. There will be 6. And prior to this, we had 8 ions. Yes, Triveni, now if you want to get the answer of it, just revise my ionic crystal lecture. Ionic crystal, yes, lecture number, I think it was 6. Just go and revise ionic crystal. After this class, you will find all your answers. You will find. Okay, tell me if you have any doubt. Any doubt, guys? So answer will be 6. Got it? Any doubt, please ask. So guys, now Frankel defect is clear and AGBR shows. So just remember these compounds. Just remember these compounds. Now let's move to the non-stoichiometric defect. And what are non-stoichiometric defect? So I told you non-stoichiometric defect are those defects due to which formula of compound get changed. Like initially it was FeO and after the defect it become 0.98. So atoms will start coming in fractions. So now I will tell you what is the meaning of this fraction. They are asking average because what is going on, Triveni, actually when I take ZNS, there will be trillions of such unit cells. There will be not one. So they are saying on an average from one unit cell, one ion is missing, right? That's why they are asking for the average. That's why they are asking for the average. Okay. Now, what do you mean by non-stoichiometric defect? Tell me, what do you mean by non-stoichiometric defect? So now I will tell you. Due to non-stoichiometric defect, formula of compound get changed. It might show up like this. So these are all examples of non-stoichiometric defect. Okay. So these are of two types. One is metal excess, another is metal deficiency. So what is metal? So guys, let me tell you, if I'm making these ionic compounds, so these are the cations and these are the metals. So what are metals? What is metallic nature? Metallic nature means tendency to lose electrons. And if somebody loses electron, it will have positive charge. So in periodic table as well, you will always find Na plus, K plus, Ca2 plus, Mg2 plus. Metals are present on the left side and non-metals are present on the right side, right? So whenever it says metal excess, it means cation excess, because metal means cation. Because metal means cation. So metal deficiency means cation deficiency, means anion is more in numbers, but still electrical neutrality will be maintained. Electrical neutrality will be maintained. So we have here metal excess defect. So metal can be accessed in two ways. So there are two ways. If there are extra metals, or another way is some anion is missing. Suppose we have 100 Na plus, we have 100 chloride. Now how Na plus can be in 100 and can be in excess? Suppose one Na plus extra added. So if one is added, it will become an 100 chloride. There is one more way of metal excess, and what is that way? Suppose one chloride is removed and you will get 100 Na plus and 99 chloride. So there are two ways. Either an anion is missing, so we call it due to anion vacancy, or your cation is in excess. So both mean same. There is no difference. In both cases, cation will be in excess. Yes, entertainment booster, we have done this. AGBR shows both. Okay? Yes. So now I'm moving to the next point, guys. Due to anion vacancy, what will happen? Suppose I'm taking Na and chloride, NaCl, and if one chloride ion is missing from here, now to maintain the electrical neutrality, initially there were 100 Na or 100 chloride, so there was plus 100, there was minus 100. But if one chloride is missing, guys, there would be plus 100 and there would be minus 99. So plus one extra is there. So what will happen? I told you that electrical neutrality will be maintained at any cost. So if that is present, if that is missing, then electron will occupy the site of that anion. And due to this extra electron, now again we will have minus 100. Right? So if anion is missing from the lattice site, to maintain the electrical neutrality, an electron will occupy that site. The electron trapped in that site is called F center. Why F center? It's a German word which means Farbe. Farbe means color. So guys, due to this electron, this crystal will show different colors. Why? When you will heat it, this electron will get excited, and once you stop this heater, once you stop the burner, now what will happen? This excited electron will again come to the ground state, and when it will come to the ground state, it will emit electromagnetic radiations, and due to which it will show different colors. It will show different colors. So guys, note it down. What is F center, Fabe center, and in which type of defect it is created? In metal excess defect. In metal excess defect. Yes, guys. Tell me now. Any doubt? Done? Any doubt, guys? So now let's move. Yes, fill in the blank. Density of this crystal will, due to Schottky effect, and yes, will increase or decrease. Tell me. Fill in the blank. Yes, Triveni, you were asking, sir, how the problems will be asked. Now I'm asking the problems. Okay. Now I'm asking the problems. So density of crystal will decrease due to Schottky effect and remain unchanged will remain unchanged due to Wrinkled Effect. Got it? Note it down. Any doubt? Okay. Got it? Got it, guys? Yes, Triveni, you were right. Just a minute. Now note it down. What is epicenter? What is epicenter? So I just told you guys cation, anion. Here we have this. So an electron is occupying this. Once an electron is occupying it, what will happen? What will happen? This is absent. So this electron oscillates and emits electromagnetic waves and it shows colors, right? If NaCl is heated in atmosphere of sodium vapors, then what will happen? Then sodium will get deposited. Suppose this is NaCl crystal and you are heating it in vapors of sodium. Now what will happen, guys? This sodium will come and stick on the surface, and on the surface this will get converted into Na plus gas and one electron. Now the one electron lost by it, now the one electron lost by it will enter into it, and one chloride inside the crystal will come out of it. So chloride will move in the upper direction and electron will move in the lower direction. It means I can say electron will diffuse inside the crystal and chloride will come away or out of the crystal, right? So that electron will occupy the position of chloride ion in the crystal, right? And due to that it looks yellow. Similarly, in presence of LiCl will look pink, and KCl in presence of K will look violet. So if somebody asks you, like if you are heating the KCl in atmosphere of K, it is looking violet due to there will be four options: metal excess defect, metal deficiency defect. So you should have idea about it. Okay, guys. So now metal excess defect. Now due to presence of extra cation, how it will be? Suppose I am taking ZNO. So ZNO will be right. So what will happen, guys? What will happen now? So when you are heating ZNO, some oxygen molecule will be escaped, and once more oxygen molecules are escaping, what will happen? O2 minus will give you O2 plus 4 electron. So guys, you will be getting Zn, but suppose two oxygen are removed, right? Initially there were 100 zinc and 100 oxide, and if two are removed there will be 100 zinc but 98 oxygen. So formula will be Zn 0.98. Actually it should not be like it. Generally it is written as Zn 1.01 something, but I'm just showing you. If you divide it by 100, so it is non-stoichiometric compound, but again total charge or net charge should be balanced, or your your salt should be electrically neutral. So electron will be there, and again due to these electrons it will change its color, right? So ZNO is white in color at room temperature, but on heating it becomes yellow. So again due to metal excess defect. Note it down, guys. It is again due to metal excess defect. Tell me, guys, if you have any problem. If you have any problem, guys, feel free to ask. Is that done now? So what is metal deficiency defect here? What is metal deficiency defect? So Metal deficiency is shown by element which exhibit variable valency. How? Now, if I'm taking FeO, if I'm taking FeO, so guys, Fe will have plus 2 minus 2. Done. Now, if I'm taking it, guys, what will happen? What will happen? Tell me. All Fe having charge plus 2 and all oxygen will have charge minus 2. Same charge is there. But metal deficiency, suppose some Fe are removed. This is missing now. Initially, guys, if there was plus 200, then there were minus 200 because Fe and O were same. But now, initially there were 100 Fe and 100 O and charge was this. But now there are 99 Fe and 100 O. So the formula will become 0.990 and you call it non-stoichiometric compound. ME next chapter I am planning to take surface chemistry because only one physical chapter is left. So I think surface chemistry is very important. This time 8 or 9 problem have been asked from surface chemistry in JEE Mains. So you generally take that lightly. We can take the surface chemistry. Okay. Yes. So guys, now it is Fe.99 and oxygen is 1. But how will it maintain the charge? Now, just like electron, you cannot have protons. It will take 4 to 5 classes. Surface chemistry will take 4 to 5 classes. Okay, Triveni. Yes. So now what will happen, guys? Fe.990. So what will happen? Now I will tell you. 2 Fe will occupy plus 3. So in these 99 Fe, there will be Fe2 plus and there will be Fe3 plus. So there will be 2 Fe3 plus and there will be 97. So guys, in non-stoichiometric compound, you will have ions of one element, more than one ions of one element. So this way, your charge will be balanced because one Fe was missing. So 2 plus charge can be balanced by 2 Fe taking plus 3 charge. Okay. Any doubt? So this is how metal deficiency defect takes place. And there was a problem over it in the IIT. Now do this one. Solve this. Let's see how you solve it. Do it, guys. This was the problem asked in IIT. Yes, do it. Yes, guys, tell me. what percentage of iron will be present in form of Fe3 plus? Yes, guys, do it. I'm waiting for your answers. I'm waiting for your answers. Yes, guys. So now, guys, I will solve it. Suppose I am having Fe 0.930. I can write it as Fe 93O100. So if the charge on 100 oxygen is minus 200, then here it should be plus 200. So guys, in 93 iron, I will have some Fe2 plus and I will have some Fe3 plus. Suppose there are X ions having Fe2 plus, and then there are 93 minus X having 3 plus. Okay, guys. So now total charge is 200. So it will be 2x 3 into, and this sum will be 200. This sum will be 200. So x will be 79, guys. So now Fe2 plus ions are 79 and Fe3 plus ions are 14. Okay. So what is the percentage of Fe2 plus? 79 by 93 into 100. What is the percentage of Fe3 plus? 14 by 93 into 100. Okay, guys. Is that done now? So guys, don't forget, today I am taking quiz. Today I am taking quiz on chemical kinetics. Very important topic. And there will be one more quiz on the mole concept or states of matter. I will take the quiz on 11 topic. Today I will be having quiz at 6 p.m. and 7 p.m. So you can join that quiz. Right? 6 p.m. and 7 p.m. we will be having that quiz. Do it, guys. Any doubt? No doubt. Done. So guys, now I'm doing the last, that is impurity defect. So what is impurity defect? This defect is due to presence of foreign atoms or ion in the crystal. Foreign means external. And how will they occupy? So suppose I am having molten NaCl. So molten NaCl will have only these ions. Right? So guys, we are having molten NaCl only. Now what you are doing? You are adding a small amount of strontium chloride. So chloride is common. Now what will happen? Strontium. If strontium is coming, guys, so 2Na will be missing because strontium is having +2 charge. So one strontium will occupy this and one will remain vacant. And if one strontium is coming, then it will 2Na will be missing. So one Na position will be occupied by strontium and another location will remain vacant. So if strontium is coming, then it is creating one void. Now guys, tell me, if aluminium would have been coming, how many voids it would have been created? So aluminium is having 3 plus charge. So 3 Na plus will be removed. And if 3 Na plus will be removed, Al3 plus will occupy the position of 1 and 2 will remain vacant. So one aluminium will cause two vacancies. No, aluminium will cause two vacancies. 3 Na will be removed. And if 3 Na are removed, suppose this Na is also removed, right? And now position of one Na will be occupied by aluminium and there will be two vacant sites. Did you get it? Tell me now. Got it? So guys, if molten NaCl containing a little amount of strontium chloride is crystallized, then some of the sites of Na plus ion are occupied by strontium ions, and each strontium ion replaces 2 Na plus. It will occupy the site of one. It will occupy the site of one ion and other will remain vacant. So cation vacancy are equal to number of strontium ions. Got it? So now solve this problem. Solve this. Now NaCl is doped with the strontium chloride. And as I told you, if one strontium chloride is coming, 2 Na will be missing. And position of one Na will be occupied by strontium and position of another Na will be vacant. Okay? Position of other will be vacant. Now what will happen, guys? Tell me. Yes, tell me, guys. So 10 raised to the power minus 3 mole percent of strontium chloride. If I am taking 1 mole, so in 100 mole, 10 raised to the power minus 3 mole of strontium chloride has present because it says mole percent of it. So 1 mole of NaCl will contain 10 raised to the power minus 6 mole of strontium chloride. Minus 5, sorry. So mole of strontium chloride are 10 raised to the power minus 5. So mole of strontium will be 10 raised to the power 5 mole minus 5 mole. So number of strontium ion will be, so it will be, so number of cation vacancies will also be same. Got it? Number of cation vacancies will also be same. Okay guys, so now let's do some problems. Tell me which of the following will show Schottky defect. Yes, tell me, guys. What is the answer for this problem? Tell me. Yes. Why? Because size of chlorine and chloride is comparable. Yes, D is the answer. Now solve this one. Tell me. Very simple problem are these. Now this topic is over, guys. So guys, here Li, so size of Li will be small, but I minus will be large. And in K plus, size of this cation and anion will be comparable. So if comparable, it will show Schottky defect, and if size difference is huge, then it will show Frankel. So that can easily dislocate. Tell me now answer. What will be the answer? So Schottky defect is more likely in the ionic solid in which cation and anion are of comparable size. So Triveni, you were asking what kind of problems are asked. Now I'm asking, right? Yes. Tell me now. A. Got it? So each and everything I told you can be used in the exam, guys. Each and everything. Now do this one. Again, this is something related to thermodynamics. Thermodynamic of defects. Yes, Triveni, now do it. Increasing temperature increases the density of point effect. Now do this. Kavya, now all redox topics are in playlist there. You can see. Yesterday I checked it. Now check it. You will see all the lectures there. Yes, including the yesterday's class. I've checked that. So I told you if you increase the temperature, then magnitude of this will increase. And as a result, more and more number of voids or concentration of voids will also increase. The process of formation of point defect is endothermic. So only this factor is favoring, and if you are increasing the temperature, more and more ions will be formed. So increasing temperature increases the point density, right? The process of formation of point defect in the solid is endothermic and has yes, and it is also the correct explanation of it. So answer will be A. Now do this one. Now do this. Yes, guys. So guys, the distance between the nearest lattice point in BCC. So in BCC, if you make it, yes, now I'm telling you in BCC what will happen? 2, 3, 4, and 1 is this. So this is the nearest neighbor distance. It will be root 3a by 2. And what about in FCC? Right? So guys, this is root 2a and this is root 2a by 2. This will be a by root 2. Now you can find which is larger. It has nothing to do with the packing efficiency. It has nothing to do with the packing efficiency. Okay. So it should not be the correct explanation. FCC has greater packing efficiency than BCC, 74%, 68%. This is true. This is true. But this is not the correct explanation. So answer will be B. Okay, Jason Jindal. Yes, Triveni, you are doing great. You are solving almost all problems. Now do this one. This problem was asked in JEE Main 2013. Do it. Do it. Be fast. The similar problem I solved you Fe.930. Now you can do it, guys. Okay. Now I will solve it. M.980. You can write 200. So if total charge on it is minus 200 on it will be plus 200. So here suppose these are x, so these will be 98 minus x. Now you can find the value of x because there is one variable and one equation. Tell me the value of x. This will be your answer, guys. 3 point something, 4 point. So A will be your answer. Yes, Jashan, got it. So I hope now you are understanding what is solid state and how you can solve the problem over solid state. Now do this one. This is very easy problem. Very easy. Cation is present in the interstitial site. Wrinkle. Yes. So this was easy problem, and if you remember these, then you can easily solve them. So guys, let's find out today's class. Oh, it's already 96 minutes. So guys, I hope you really enjoyed today's class. And if you really enjoyed it guys, then please don't forget to share it and like it so that your other friends can also learn from such classes. And guys, click on the bell icon so that you can get latest notification of our lectures. Okay, and we are there on the Telegram app as well. So on the Telegram app, yes, you can join us, and our channel name is JEE underscore English, and the link for that channel is given in the description part of this video. Okay, so there are simple steps how you can subscribe to Unacademy. Just go to Play Store or App Store, download Unacademy's learning app, guys. Once you download it, install it, and after, yes, this topic is over now. After doing this, install it, and after installing, you will be teaching on this page. On this page, click plus. So once you are clicking plus, you will be getting IIT JEE and NEET UG, right? So check the IIT JEE box because we are preparing for it, and then hit the subscription button. Then hit the subscription button. Once you are hitting it, guys, then for 2 months, sorry, then for 2 year, if you are applying my code Rahul Kim, then you have to pay 50,000 rupees. Yes, if you are applying it, guys. Yes, solid state completed Anu. Yes, guys. So just remember this code, guys. Remember this code. For 1 month, for 1 year, you have to pay 34 instead of 38. For 2 year, you have to pay 50 instead of 56. Don't forget this code, guys. It will help you to get a discount. Okay. Thank you everyone for your compliments. Don't worry, I will keep on doing this and you guys will keep on learning. Okay, guys. So, guys, just apply this code. Just apply this code to get the plus subscription, guys. And you have to pay 34,000 for 1 year and 50,000 for 2 year. Now you can also pay your fees in the part payments, guys. Once you are part of subscription plan, guys. Yes, what will you get? Your course would be structured and your every fourth class would be doubt clearing session. Number two. Number three, you will have weekly quizzes, live quizzes, and after every completion of every topic, you will have a mega quiz. Okay, guys? Yes. Once you have mega quiz for that, mega quiz is done, and that is the most important part is the test series. So, guys, you will have access to the test series and video lecture and content of not just my video lecture, but you will have access to the video lecture and content of all the educators. Okay, guys? So these are all the benefits which you are going to get, guys, and I hope you really enjoyed this topic. Solid state was something you need to visualize it in 3 dimension, and if you can visualize it in 3 dimension, guys, then it is great. And if you can't visualize it, then it would be difficult for you guys. So I hope you guys really enjoyed this topic, and in the next class I'm planning to start surface chemistry. That is also important topic, surface chemistry. Okay, guys. So once our surface chemistry is over, guys, what we can do, then we will start inorganic part. I will take metallurgy, coordination chemistry, because these two topics are very important. D and F block also we can take. Okay, definitely we will take everything. So guys, take care of you. Bye bye. I will meet you again, and don't miss today's quiz, 7 p.m.